Good afternoon, everyone. So, last session we completed till data frames. We saw how to prepare data frames. Let's start from where we left. Again, we'll do couple of syntaxes of data frame, what we covered in last session, and then see further details. Okay. So the syntax, what is a data frame? Data frame is nothing but a table. In SQL, we call it table. In SAS, we call it as a data set. Okay. Data frame can be considered as a set of vectors which are combined in columns. So here we have got serial number as vector, where we have put values 1, 2, 3, name as another vector, age as a third vector, and now we are combining these three vectors using a function data.frame. In data.frame, what we are passing parameter is serial number, name, age. These three vectors we are passing. It will combine and we get a PM data frame. This syntax is already with you. If not, just type it. Just open the same editor that you had last time. I'll also do along with you. So this is the syntax that we have to run. This 5 lines, which is highlighted. Yeah. Shortcut to run is Control R or Control Enter, depending upon what you are using, R Studio or Basic R interface. View used to see that same thing in a tabular grid-like format. So the moment I say view, you see a grid-like format which opens up. Okay. View V has to be capital. Class is to see what is the class of the object. Here the name of the object is PM. So when we say class PM, it will say data frame. How do we refer a particular cell of a data frame? For example, this is like a Excel sheet. This is like an Excel sheet. If I want to refer a cell where the value is 43, I have to specify what is the row index, and then I have to specify the column index. The row index is third, column index is this is 1, 2, 3. So this will be 3 by 3, 3, 3. If I want to refer this cell, the row index is 2, column index is 3. Here first we have to specify row index and then the column index. Very simple to remember. In Excel it is column then row. R is opposite of Excel way of referencing. So here when I refer PM 1, 2, for the time being ignore this levels. I'll explain what this levels is when we come to the section called factors. Okay. Okay. So I think so we have done with these syntaxes now. Okay. Yeah. R. Yes. Yeah. Yes. No. So if you are opening that interface, that will create its own workspace. But yeah, if you shut down and then restart things in RStudio, probably yes. Okay. Reason being, when you shut down and restart RStudio, what happens is in tools, global options, actually RStudio is nothing but a graphical user interface. In the background, it is making use of the same package of R. So here you see it is making your C programs R 3.3.2, this version. This is where my R executable is stored. Okay. And when I open it with the same version, for example, when I open it using the basic R, this one, the basic R interface, and if I use the same version which is mentioned here, what will happen is when I shut down, all data sets gets written to hard disk, and there is a default path where it will be written. When you restart, things get read only from that default path. Okay. Working directory is the default path. The moment you change the working directory using a setwd command, the moment you change the working directory using setwd command, the the image where things will get stored, basically all the content of the workspace where it will get stored, will then get stored in the working directory that you have set. Okay. Done. uh, ls is to see all the objects which are there currently in the memory. So if I just run ls, no, I've not yet run. Yeah. So it shows these are certain objects which are there in my memory. Okay. Yeah. Okay. Now I have got PM as an object, serial number, name and age. These are my objects. Let me just remove some objects which are A, B, C. Okay. Now the number of objects that I have got is only age, name, PM, serial number. A basic fundamental question. When I do view PM, this serial number which is here in PM, this serial number is now in the PM data frame. The name is in the PM data frame. Age is in the PM data frame. Is this three columns same as, when I'm saying same as, I mean, are they pointing to the same object, serial number, name and age? No. See, when you call a function, you pass parameter. The function makes use of those parameters, makes use of those values, do some processing and creates a new object. The new object, serial number, name, age, is the columns in the new object. Serial number, name, age are the columns in the new object, whereas serial number, name, age are independent objects also. To explain it better, let me use an Excel example. I create a serial number column. This is a cell. Then I create name somewhere here. I then create age somewhere here. Something. Now I create a table. And this table I want to name as PM. So I'm just nicely formatting and doing it. So I'm saying this column I want to create a serial number, name, age. Okay. And I'm saying the values of this should come from here. Okay. Now here all these are being referenced. All these are being referenced by referring to the same pointer location where the information is stored. Yeah. But if I do this, Control C and paste values. Okay. Now if I delete this, will this age 65, 43, 41 get deleted? No. So what happens is when you are calling a function, the parameter is going, the logic in the function is making use of the values. Okay. The values are being made use of and the new object is created. Now this new object, this serial number is different from this serial number because here the referencing is not by pointer. There is a concept called pointer. What the concept of pointer is, and that pointer concept is actually in C++. What the concept of pointer is, if I have got an object and I then create another object which is referring to it, and both of, because this is referring to it and this is having some value, if I make change in the value, values for both of them will change. But here I'm calling a function. In function, when you pass parameters, values of it are used, not the pointer to that memory location. Because values are used and not pointer to the memory location, this column and this object, they are two different identity. Are you getting? I hope I'm not complicating. Govardhan? Yeah? So if you are not still able to understand, then always understand in the functions in R is always paste spatial values kind of thing. Okay, the functions in R is always paste spatial values. It will make use of values, create a new object. The old object has its own identity and new object has its own identity. Yeah. So here, if that is the case, if I now drop serial number, will the column serial number from PM data frame will get dropped? No, it will not get dropped. Again do view PM, the column will remain. V is capital. Okay, so when you do this, you see the column does not get dropped. Yeah. So basically here I have got serial number, name, age. I'm now saying I'll drop serial number. If I try to access serial number again, what will it say? Object not found, because serial number object was dropped. But if I try to access serial number column is different and object is different. Here PM is the object. In that object, serial number is a column. So this serial number, if I access, it will give me the values. Yeah. So just try these syntaxes from here till here. Just try these syntaxes. Yeah. Okay. If I want to drop serial number column from the data frame PM, how do I go about dropping it? If you run the syntax bracket PM dollar serial number, if you use that syntax, the column will not get dropped because RM is removed from memory, and from memory you can remove objects. Serial number is not an object. Serial number is a column. So to remove a column, you have to set it as null. Okay. So if I try RM PM dollar serial number, I've got the syntax here. So rather than typing, I'll use the syntaxes from here. If I run this syntax, it is going to give me an error. It must contain names or character strings. Okay. If I have to drop this, the syntax has to be PM dollar serial number. I'll set it as null. If you recollect, you wanted to drop the second row of a list L1. When we dropped that, we set null. Yeah. So similarly, if you want to drop a column, you have to set it as null. Yeah. So after having dropped, if I see that only there are two columns, name and age. The serial number column is no longer there. If I want to bring back the serial number column, how do I get it? I have to use cbind. Cbind is a function which is column bind. Cbind is a function which is column bind. Now if I run this, what will happen? I'll get an error of whether the serial number column will get binded to PM data frame. Just think. Cbind definitely is a function. It's a valid syntax. It will give error. Why? No. In our previous step, we dropped the serial number object. So what will it say? Object not found. Your binding PM data frame exists. If you run this ls command here, serial number object is no longer there, right? So you have to recreate the serial number column. So basically you'll have to run this syntax again. So recreate the serial number object. So you'll have to rerun this syntax. Once you have done, serial number object is now available, and now if you run this code, you will be able to bind it. Okay.
When you start writing a function, you get a drop down
Yeah.
which helps you. How can you select it? Can you select it or is it just
You can. No, you can select it.
double clicking on it doesn't really
No. Say I want to do this. PM cbind tab. Just press tab. PM comma tab. Done. Yeah.
cbind is undo kind of thing?
No, cbind is not undo. It's column bind. Cbind is column bind. Yeah. Now, when you see this data frame, serial number column is last. I've got name, age, serial number. Okay. Here, very simple concept. First, for the time being, we'll now move out of R at some basic concepts. Whenever you create a table or a data frame, basically something which contains data, you should always have some column which is identifier column or something which you can refer. Okay. For example, if you create a employee master table, which column in that table will be a identifier for all the employees, will be able to help us uniquely identify each and every employee. ID, employee ID column, because any given employee will have a unique identifier. It is quite possible in a given organization there can be two Rajesh Jakotia. That is quite possible. So name cannot be a unique identifier. As such, a identifier has to be given. Okay. Now whenever there is a identifier, it should always be the first column. From a best practice point of view, from a design point of view, for example, if I say employee master table is there, and now I give the employee data like this. Place, city where the employee is working, name, date of birth, employee ID, joining date, salary, and so forth. Will you be able to connect this data easily? You're first having city, then you are getting name, then you are getting date of birth, then employee ID, then salary, then years of experience. Probably ability to relate this data when you see it may not be easy, because the right sequence would have been employee ID, name, place of date of birth, place of work, salary, and so forth. Because we are used to connecting things in a sequence. If data is not in a sequence, okay, then we'll not be able to relate it. Gopal, you work on collections data? Uh, but a bit. If you get a collections data of customers from whom you have to do collections, you don't know the customer ID, you don't know the account number. I assume these two fields are there, customer ID and account number. But the sequence of data is given as days past due, amount to be collected, date when it was to be collected, which branch the customer belongs to, then his name, then customer ID, then account number, then loan type. Will you be able to easily work with it? It will take time, because natural thing is you want account number or customer ID first. Because the moment you see this column, you can punch in CRM, or you can quickly relate based upon customer ID or account number sequence. Many times account number sequence also tells the initial codes say which type of account is. Then you say name, because when you call, the first thing you want to say to the person is the name of the person. Then you have to say this is the type of account you have, and then this is the amount you want to collect, right? If that sequence is not in the way we speak, it becomes difficult. So this syntax which we have now is to rearrange the columns. Okay. If you learn the syntax as a syntax, you'll never learn. But if you learn the syntax thinking why we have to rearrange columns, then you understand that there is a requirement that if the data is not in a proper sequence, then ability to connect with the data is not easy. That's why you should always have an order. Now, if you agree that, then the syntax, then you will say, okay, syntax. Why is always important, then how, and then what. So why is now understood. So now let's see how we can rearrange. In a data frame, as I said, every row is referenced by a row number. Every column can be referenced by a column index. And then there is a row position and a column position. Now when I have this syntax, let's just focus on this much part. PM, bracket open, and there is a bracket close. There is a row position. This part is basically row position. And then there is a comma. And then this part where there is something I have written is a column position. Now in this syntax, I'm not putting anything in the row position. I'm not putting anything in the row position. If there is nothing in the row position, what it means, the syntax has to impact all the rows. This code has to impact all the rows. Okay. Comma. C312. Now here C312, when I write this in the column position, what I'm saying, first I'm referring the third column, then I'm referring the first column, then I'm referring the second column. Pick these columns in that order. Okay. So this part of the syntax, if I do this and just run this much, it is going to pick third column, first column, second column. Okay. Here I did not assign it to anything. There was nothing. So there was no variable to catch the object. Because there was no variable to catch the object, it got displayed on the screen. If I would have written this like syntax as PM1 instead of PM equal to PM, I just put 1 here. If I run this, what will happen? PM1 object is now going to catch. I'll have a new object PM1 created. Let us just see PM and PM1 both. There will be no change in the sequence of the PM object. This remains same, but there will be change in the sequence of PM1. Right? Yes? Uh, just do type PM and see how many columns are there. Yeah, because you dropped 2 columns probably. That's the problem. That's the reason. Okay. In the meantime, all of you try. I'll just check it.
I just have one question. So when we were deleting the column serial number,
Yeah.
so suppose there's only just one column which we want to delete, so we assign a random value. So suppose we want to delete multiple columns at a single
Yeah.
row, then how do we go about it? So suppose we want to delete 10 columns.
We'll see that.
Yeah.
See, error did not start here. Error started somewhere down. Error started here. You said PM is equal to C by PM. Serial number. You did not say PM equal to C by PM comma serial.
So if I were to edit it here, what do I do? PM.
Now you have to go ahead and run it up. Because you have already corrupted the PM data frame. So you have to again run this step. Okay. And then correct the syntax where it went wrong. Where it went wrong.
This one, right?
No, see this is console. In console you cannot keep changing. In console you can change things only at the cursor level. So here you were supposed to write the syntax like this.
See the table name here. This is the table name and this is the column name. When I do this, it's not coming. The table is not coming.
See, name object is there.
Yes.
You have a name object, for sure. Name is there. Where is the table object? Table object is a general. You have to go to segment table. Do that. It's happening. Done.
When I'm doing YouTube,
What object is going to be created? Just go to code. Go in the code. PM equal to G by table. Output of this is getting stored in PM. You have to modify table. View PM.
so the H here and the name H here.
So here, when I wrote this syntax as PM1 is equal to PM, see the entire objective here was realign the column. But in this step, I created a new object PM1. If the same object PM would have been say 200 MB, it would occupy 200 MB in the RAM, and I'm now saying PM1 is equal to PM and rearranging the column. Another PM1 object in RAM would have got created. It would also occupy 200 MB, unwanted wastage. And that's the reason when I actually initially gave the code was like this. When this is the kind of syntax, first what happens always, the right hand side part of the code gets executed. When right hand side part of the code is executing, is PM object there? Yes. So this will get executed, a object gets created. Now this object I am assigning to which variable? PM. So what will happen? Old object will go in garbage and the new object will get attached to PM. Unwanted memory wastage is also avoided. Yeah. So that's the reason when you are just rearranging columns and you are very sure that you are just rearranging, instead of creating a new object, overwrite the old object. Yeah. Okay. Okay. Now if I want to create a new column, I want to introduce a new column in this, and that new column has to be created for each row. Okay. In Excel, how we go about doing it, say I want something initials. Okay. In Excel, what we would have done is equal to, we would have used some function, say left returns a specified number of characters from the start of a string. Okay. So left, I want from the start of the string, comma, I want one character only. I would have written this. Only one character of that NM would come. In second row, the value is not yet populated. What I have to do? I have to copy paste. In third row, it is not populated. What I have to do? Copy paste. This is Excel. In R, I just want to create a new column. This column has to be created in which data frame? PM. A column in a data frame is always referenced by $. So I have to say PM $, the column name. So here I am saying PM $F initial. Just like in Excel we found a function called left, I will have some corresponding function here also. So I'm using here a function called substring. Okay. So in substring, I'm saying start from character first, go till character first only. Start from character first, go till character first only. Whatever is the substring, take that value, assign it in this column. And this will happen for all rows in one go. I don't have to say for row 1, row 2, row 3, just as I Excel I manually copy pasted it. Here when the moment I do it, this will happen for the entire data frame. A new column PM F initials will get created. Likewise, I have now used a substring function and then set 2, 2. So I'm saying start from character 2, end at character 2, which means only one character has to be read, right? So this, and now when I see, you see 2 new columns has got created. For all the rows, the values are populated. Yeah?
Did we create an object of initials?
F initial is what? Is it an object or a column?
Column.
Column is a column. Object is what? PM. Here PM is the object. In that object I am creating F initial. PM object already exists. So in an object I can create a column anyway. I can simply say I want to create a column PM dollar call is equal to 1. If I just run this syntax, what will happen? A column named call will get created. For all rows, the value will be 1. Because there is no logic here. Here there was a logic. So that logic is going row by row. It is taking the value of that row, name, and then applying this function, getting the value, assigning to that row F initials. Right? Here because it is 1, everyone will get the same value 1. A column can be created at any given point of time in a data frame object. Column is only part of data frames. Okay. If you say vector XYZ object, there are different types of object. That object does not have a tabular structure. You cannot add column, right? Okay. So here we have seen how to go about dropping a column. We have seen how we can do cbind. We can reorder the columns. We can create new columns. At times we may want to insert data. Okay. For example, I get transaction data on a daily basis and I import that data from some file. And as I import from file, I create separate data frames. Data frame transaction 1, data frame transaction 2, data frame transaction 3, and then I want to append them so that I can create a data frame for the entire month. In that case, you have to use a function called row bind. Okay, rbind. Rbind stands for row bind. So here what I've done is I've simply created one row where in this row values for all the columns are there. Serial number, name, age. The structure of this has to be same as the structure of the previous one. I'm creating as a list and then I'm casting it to data frame. And then I'm adding existing. PM is a data frame. This is a data frame and I'm saying row bind them, which means first data frame, row bind the second data frame, and get me a new data frame where rows of both of them are present. Okay. अब आपके पास data है. Okay. Some data is come to you, and then another file has got some other data, but same structure, same set of columns, but this is for say first week of January, that is the second week of January. Now you want both the data to come one below other. So to do that, you require a function called rbind, and this process is called append. Typically we use the word append, and rbind means row bind. So the columns are structure is same, column names are same, you're just putting one below other. So here what I'm doing is I'm creating this record. If you see, the columns names are same, serial number, name, age, F initials, L initials. This is what I have in PM. These same set of columns. Only thing is there are 3 rows here and the 4th row is here. I want the 4th row coming here. All the information of that 4th row should come below this. And to do that, you require a function which is called rbind, that is row bind. Okay, so that is what I'm doing here. So just try this command, row bind. This plus in this syntax is not to be typed. This plus comes up automatically because my syntax is in multiple lines. For example, if you see this syntax which is like this, I'm now creating a new row, and then here this entire syntax is in 2 lines and the plus automatically came here. So the plus is not part of the syntax. Yeah, and then I'm doing a row bind, and then I see I get 4 rows. So this is the part of the syntax which is selected part you have to execute.
Rajesh, can you scroll the editor a bit? I want to see something.
Just 1 minute. Yeah, tell me.
Can you scroll the editor a bit? I see something. Got it.
NR is a function.
NR is new row, object name. Yeah. See, function, very easy to understand. What is a function? If there is a bracket open and a bracket close, is a function.
Okay, understood.
What does NR stand for, you said?
New row. I just gave an abbreviated name to that object. NR is an object. I'm giving an abbreviated name, new row. Okay. So just to summarize, C function adds values, sequence of comma separated values, head to tail. cbind combines columns, and rbind adds rows. Yeah. Now let's see a function called attach and detach. So far what was happening is, if we want to refer any column, we had to keep mentioning the data frame name. So if I want to refer a column, I have to say data frame $column name. That is how I have to refer it. If I have got a big data set, and if there are lots of column I have to refer, then it would become too cumbersome. And if the data frame name is also big, in that case it would become too cumbersome, because a big data frame name, dollar, column name. Data frame name, dollar, column name. You have to keep referring it. Is there a way by which I can refer column names without constantly prefixing it by data frame name? There is a way. That is to attach the data frame. Okay. So what does attach mean? The moment you attach a data frame, the columns inside that can be referred directly. Okay. So here, when I say attach PM, this syntax, I get some message also. And this message is the following objects are masked by global environment. What does this message mean? The following objects are masked by global environment. By default, any object you create goes in global environment. Yeah. What are the objects that you have in your global environment? These are the objects that I already have in my global environment. Is there a serial number object there? There is object. And what did I say? Attach. What do attach do? The objective of attach is that I can refer columns of that data frame without prefixing data frame name. Yeah. So my objective is this column of PM I should be able to refer directly. But unfortunately, there is an object by this name already existing in global environment. Now when I type serial number, will the system not get confused whether I am referring to serial number column of PM data frame or the object? It will. To avoid confusion, what do you do? Table name, dollar column name. But the entire purpose of attach was to be able to refer column names directly, right? So the only challenge is if a column name in a data frame, if there is an object having same name as a column name in the data frame that you are attaching, in that case, object will have a higher precedence. What I'm trying to say is PM data frame is there. There is a column serial number. When I attached it, the objective of attach is to be able to access columns of a data frame without prefixing the data frame name. That is the objective. But now when I am attaching it, it giving message that following objects are masked by global environment. Why is it giving this message only for these three columns? It is not giving for F initials and L initials. Because there is no object by this name. For age there is an object in memory. For name there is an object in memory. For serial number there is an object in memory, which means age, name, serial number columns of PM data frame cannot be accessed without prefixing the word PM. Only F initial and L initial can be accessed. Govardhan, for you, is there a F initial object?
No.
I'm still accessing F initials. It should give me an object not found. It will not, because this F initial is referring to PM. And if you want to confirm, the values are same. Why I have been able to access this?
Because
I did attach. So when we attach it, I get this message, which means I cannot access these three columns directly. but I can access other columns directly. Yeah. So now when I say serial number is equal to serial number plus 1, which serial number will get impacted? The serial number object or the serial number column? Object, because that serial number is already there. Object will have a precedence. If the same thing already there, then object will have a precedence. That's the reason why it is giving you a message that these following objects are masked, which means these columns cannot be referred directly, otherwise all other columns of that data frame can be referred directly. Yeah. So when I do serial number is equal to serial number plus 1, and now I see the PM data frame again, there is no change in my PM data frame. Yeah. But there is a change in the serial number object. The values were 1, 2, 3, now become 2, 3, 4. Yeah. If I remove serial number object, RM serial number. If I remove serial number object using this command RM serial number, now if I refer serial number, what message should I get? 1, 2, 3, 2, 3, 4, object not found. It should now give 1, 2, 3, 4, which is from the PM data frame. Why? Because I'm still in attached. Of the PM object was attached, and now serial number column can be accessed directly because the object is no longer there. Right? So this is the concept of attach. Yeah. And the moment, see, typically this attach, detach, when you are going to use this attach and detach concept when you want to refer many columns of a data frame in some function or in some regression process, whatever you're calling, and then you don't want to keep prefixing it. PM, 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 or data frame, data frame, data frame name. You don't want to prefix it. That time you will do this. Okay. The moment it is done, moment your work is done, detach. The moment you detach it, now if I run this serial number, what will happen? Object not found. Why? Serial number object is already deleted. Now we are also detached things. So it will say object not found. Yeah. Just try these syntaxes from attach to detach. These set of sequence of syntaxes, just try and see the output. Okay. So we have done attach and detach. Now let's again, before this, again there is an attach command that I have run. Okay. Assume. And then after doing attach, I run serial number equal to serial number plus 1. Serial number object is already deleted. So when I say serial number is equal to serial number plus 1, which serial number will get impacted? Yeah. So now which serial number will get impacted is the serial number column of the PM data frame. Okay. So let's try that. So I am again doing attach PM. The following objects are masked, age and name, because those two objects already are there, but serial number object is not there now. So serial number, F initial, L initials can be accessed directly. Now I say serial number is equal to serial number plus 1, which means serial number column of PM data frame is being referred. Yes, which means all values of serial number should be incremented by 1. But when I do PM, the values are still 1, 2, 3, 4. The values are not changing. Why? But if I just say serial number, I see the values as 2, 3, 4, 5. When I just say serial number, the value is 2, 3, 4, 5. But when I say the serial number, when I see the serial number column in PM data frame, the values are still 1, 2, 3, 4. Why is it so? Now there is a concept of view, V-I-E-W, and this concept is there in databases also. This concept is there in databases also. What is the concept of a database and view? Basically, views are queries which are written on a table to extract information from the table. If you make any change to the view, it will make change to view only, but it does not make change to the underlying, which is that underlying table. So the same concept of database is used here also. When I do attach, a view of that object is created. I am able to access the columns of that object directly without prefixing the data frame name. Any change I make without referencing the data frame name means that I'm now making change to the view column. But the change is only to the view column, not to the underlying. As such, when I did serial number equal to serial number plus 1, there is no impact on PM. The PM data frame serial number remains as it is, but yeah, the serial number column which I was indirectly referring without giving the data frame name, over there is a change. So the point is, if you want to make a change to the underlying, you have to always refer the column names by prefixing the data frame name. So if I want to make that change, I'll have to say PM dollar serial number now equal to serial number. This serial number is basically the attached serial number, and this serial number is actually the actual serial number of the data frame. So now the values will get changed, and then I say PM values are 2, 3, 4, 5. Yeah. So this is the concept of view, attach, and once I have done complete attach and all the things are done, end of attach, if your work is done, you should say detach. So from here to here, just type the code, see the output, make a understanding of that output. Okay. Now let's understand one more complicated concept called factors. 15 minutes. Let's understand one more complicated concept called factors. I'll try to simplify this. Say you have got a database of, say, employee master, and assume the company is like a TCS, Wipro, Infosys, HCL, who has got 100,000 employees and more. Okay. Now assume there is a column which says education qualification, and for the time being I just assume that the qualifications are undergraduate, graduate, postgraduate, missing. The database of employees is, say, 100,000. Assume hash employees which fall in these categories are 25,000 each. How many bytes the word undergraduate, how many bytes of memory the word undergraduate will occupy?
How many bytes
Yeah.
divided by 256?
One character occupies 1 byte. If you are not following Unicode format, if you follow UTF-8, that is Unicode format, in that case 1 character will occupy 2 byte. The UTF-8 format is, if you want your database should handle not just English characters, but also it should handle any other characters. Hindi, Chinese, Marathi, Arabic, any other characters it has to handle, then it has to be a 2 bytes. Because the initial 265 bytes, 265 bit combinations is reserved for English characters, 1, 2, 3, 4, 5 numbers, and many special characters. Okay. So here it is going to occupy 13 bytes. So I can simply get the bytes as length of the text. Yeah. So if I have got the database has got many columns, for the time being I just assume only there is one column which is qualification, and 25,000 observations are undergraduate, the characters undergraduate coming, character graduate coming, and so forth. What is the total space that file will require? If these things come only one time, the total byte will be 40. Okay, just to prove it, Mr. Gopal, just focus. Just to prove this, what I'll do, I'll copy this. I'll remove all of that because enter new line is also occupy space. Okay, if I just do this and save, say I save it at desktop abc.csv, abc.txt. Save. This is encoding. Can you see Unicode, UTF-8? So I'm using NC encoding, which means one character will be 1 byte. So I save it. I close this. Discard properties. 42 bytes. Okay. So that because of the new line, we had 2 bytes extra, 42, but otherwise it is 40. Yeah. If there are 25,000 observations, so total bytes for these 25,000 observations will be this many. For this it will be this much, this is this much. So which means that one file will have these many bytes. Let me move this here. So total bytes how many KBs this will be? this divided by 1024 MB, this divided by 1024. Okay, so this much. Now let us see if I can say undergraduate, I have a mapping code. I have a mapping code for it, and I say undergraduate is given 1. This is referred as 2. This is referred as 3. This is referred as 4. To save number 1, how many bytes are consumed? 1. To save 2, 1. 3, 1. 4, 1. Which means the entire size for mapped bytes would be this multiplied by this. So total bytes, kilobytes, all the calculation would have worked like this. Saving in space would be, instead of occupying this much space, okay, now I'm going to occupy, sorry, instead of occupying this much space, now I'm going to occupy. So earlier I was occupying 4 times higher space, 4 times space. So 3x space, this much. The saving is this much, 71 MB, 0.71 MB. Now this entire data, if you take it in, for you it may seem that 0.71 MB for 100,000 observation is small, right? But this 100,000 assume becomes 1 million. This would be 7.1 MB. If it goes more bigger data, it would be much more higher. I am able to do the entire work with 1/4 of the RAM as against the earlier scenario, because R is in-memory processing. If I load this data in memory, it is going to take 976 kilobytes. If I make it as a factor, which means I convert them into 1, 2, 3, 4 format, it is going to take only 244 kilobytes. Memory consumption will go down, right? And R, because it is an in-memory processing, which means the most important resource for R is memory. As such, to retain and reduce the consumption of memory, R converts such character variables into factors automatically. R converts such character variables into factors automatically. Yeah? Have you got the concept of factors? Yeah? So coming back to this, factors. In R, character variables are by default stored as factors. Now, if character variables are by default stored as factors, what is the downside? There is one downside. Say employee ID. Employee ID has got variables, values like EMP001, EMP002, EMP003. These are characters. So employee ID by default will be stored as factor. Now if employee ID by default is stored as factor, and the data table that we are working on is, say, employee master. In employee master, all employee ID is unique. To keep this mapping that employee ID EMP001 is 1, EMP002 is 2, in memory it has to create a mapping table. because that mapping table only will be able to say what is 1 and what is 2. Now each employee is unique. For that you are giving another number 1, 2, 3, 4, 5, and then you are keeping a mapping table. It is not saving memory. It is nowhere saving memory, because if by default you would have typed here EMP1001, EMP002, EMP003, all of them is occurring once only. Benefit of factor occurs for categorical variable, that is variables which have got categories. As I said, employee qualification. It has got categories, as I said, undergraduate, graduate, postgraduate, missing. Or even if it would have been having some junk, it would have had 8 or 10 categories only. The mapping table will have only 8 or 10 categories. It would not be as big as 1 lakh observations. But if employee ID is converted as a factor, the mapping table will have 1 lakh observations of employee IDs. So identifier column should never be a factor. Only those columns which has got certain categories, few number of categories, those columns should be converted to factors. Downside, there's a downside, but can we overcome it? Yes, you can overcome it. R provides you syntax by which you can say which column you want to convert as factor, which column you don't want to convert as factor. Okay, so that is left up to you. We'll skip this syntaxes. It's too complicated. Concept is understood. We'll see this factor as we import some data. Yeah.
But by default it is factor.
By default it is a factor. You have to override the factor thing. Yeah.
Let me understand this. Columns which can be categorized in some shape or form, they can be converted to categories.
So we'll take a break here. After the break, we'll see how to go about importing data.